This is Lesson 1, an introduction to propositional logic. So, we've just reviewed the structure of formal logic. Formal logic is broken up into deduction and induction. In deduction, we've broken up into propositional and categorical logic. We covered categorical logic in fine detail in the Introductory Logic, the Fundamentals of Thinking Well course. For categorical logic, the basic unit of thought is the term, or the category. When you abbreviated statements, you shortened subjects and predicates down to terms. For syllogisms, it was the major term, the minor term, or the middle term. But that's for categorical logic. In propositional logic, the basic unit of thought is the proposition. Let's see what we mean by that. As with all of life, we get to start with the definitions. That's what we're doing in Lesson 1, so that we have the raw material, the grammar of logic, to go on to the next step. First definition is proposition. Put simply, a proposition is a statement, a sentence that is true or false. Now, the same proposition can be represented by several different sentences. For example, God loves the world is loved by God, and Deus mundum amat are all basically the same proposition, even though they're three different sentences. That's because they mean the same thing, basically. Now, a proposition can be a simple proposition if it has only one component part, like the statement, God loves the world. Or a proposition can be compound if it has more than one component part, or it can be modified in some other way, like the proposition, God loves the world and God sent his son. The thing that modifies or combines propositions is called a logic operator. So, God loves the world and God sent his son is, of course, a proposition. It's a statement that's true or false, both halves, but it's also a compound proposition. Compound meaning it has more than one component part or is modified in some way. The proposition we're looking at right now is compound because it's really two simple statements that are being combined with the logical operator and. Now, for a more technical definition. A proposition is truth functional when its truth value depends on the truth value of its component parts. So, it's a truth functional compound proposition because the truth value of God loves the world and God sent his son depends on the truth value of the component halves. So to rephrase one more time, the proposition God loves the world and God sent his son is a truth functional proposition consisting of two simple propositions, God loves the world, along with God sent his son. And these two simple propositions are combined by the logical operator and. And is one of the many logical operators we're going to be learning about in these next few lessons. Okay, similarly with this second example, it is false that God loves the world is also a truth functional compound proposition. It consists of this simple statement, God loves the world, modified by the logical operator, it is false that. And as a logical operator, it is false that is a different logical operator. Now, with this one, we haven't combined two simple propositions. We've taken one simple proposition and modified it by the phrase, it is false that. And that modification makes it a compound proposition. Now, if the simple proposition, God loves the world, is true, then the compound proposition, it is false that God loves the world, is false. That shows that this is a truth functional proposition because its truth value depends upon the truth of the component parts. However, the proposition, I believe that God loves the world, is not a truth functional proposition because its truth value does not depend on the truth value of the simple proposition, God loves the world. God loves the world could be true, God loves the world could be false, but if you put I believe that God loves the world in front, it's a self-report. And we tend to take self-reports to be true. Someone could believe that God loves the world, whether or not it is true that God loves the world. But it is still compound because it's modified by the phrase, I believe that. And so I believe that God loves the world, though compound, is not a truth functional compound proposition. You see how these terms are starting to work together? Now remember the difference between categorical and propositional logic. Categorical logic uses individual letters to abbreviate terms. Propositional logic uses the proposition as the basic unit of thought, and by that I mean that we use letters to abbreviate whole propositions, not just individual terms. So another definition for you. A propositional constant is an uppercase letter that represents a single given proposition. So the statement, the mouse ran up the clock, could be represented by the constant m. The mouse did not run up the clock would then be squiggly line M, where M is still a propositional constant that represents the statement the mouse ran up the clock, and the squiggly line, the tilde, is the negation. On the other hand, a propositional variable, as opposed to a constant, is a lowercase letter that represents any proposition whatsoever. Usually, with propositional variables, we start with the letter P and we work our way down the alphabet Q, R, S, and so on. Lowercase. We use propositional variables not when we're representing some known proposition, like the mouse ran up the clock, but when we're considering the form of the proposition and the form of the argument on the whole. So the propositional variable lowercase p could represent God loves the world, or it could represent the more compound proposition God loves the world, but he hates sin, or any other proposition that exists. Now, the complicated proposition, it is false that if the mouse ran up the clock, then if the clock did not strike 1, then the mouse would not run down. That could be represented by the propositional constant f, and that one constant could represent that entire proposition. Or it could be represented by the more complex simplification up there, representing each part. Maybe you're thinking, I'm going to choose the single letter every single time. And you're right, it looks easier, but it all depends on what you want to do with the proposition and how you want to analyze it. Figuring out why is the goal of the next couple lessons. But for lesson 1, we've just learned the definition of several terms that you'll need to understand in order to understand the rest of Unit 1. So I'm going to review them now. Okay. First of all, a proposition is a statement. It's a sentence that is true or false, a sentence that has a truth value. Propositions are truth functional when the truth value of the proposition depends on the truth value of its component parts. Propositions are either simple or compound. They are compound when they are modified or combined with other propositions by means of logical operators. A propositional constant is a capital letter that represents a single given known proposition, usually with a known truth value. A propositional variable is a lowercase letter, usually P, Q, R, S, and so on, that represents any proposition whatsoever. So let's consider exercise 1. What are the two main differences between propositional constants and propositional variables? You can identify probably 3 differences between them, but I just ask you for 2. Numbers 3 through 4 modify or add to the simple proposition, we have seen God, to create the following. Number 3, a truth functional compound proposition, and number 4, a proposition which is not truth functional. So make sure in both of those you use the phrase, we have seen God, and then modify that. To be truth functional, make sure that the truth value of the first one depends upon the truth value of we have seen God. Then when it's not truth functional, add to it to make sure that the truth value does not depend on that statement, just like we did in the lesson. For numbers 5 through 10, circle S if the given proposition is simple, circle C if it is compound. Remember that a compound proposition uses logical operators to modify or combine simple propositions to make them compound, and don't get fooled by the length. For example, the Lord will cause your enemies to be defeated before your eyes is a long statement, relatively, but it's a simple statement. You could abbreviate it in categorical form, and there's no logical operator that's modifying it. Try to identify whether the statements are simple or whether they're compound, either, of course, by being combined or modified with some logical operator like it is false that. Finally, for numbers 11 through 15, I'm teaching you how to begin to abbreviate propositions using propositional constants. So identify 4 propositional constants for you. B means the boys are bad, M means the man is mad, G means the girls are glad, S means the students are sad. Each of the numbers are abbreviated, and I want you to expand them to complete propositions again. So for example, with number 11, it is false that B, you could write out as, it is false that the boys are bad, or you can make it more simple and just say, the boys are not bad. On to the homework.